So suppose we have given the differential equation d2y by dx square plus p of x into dy by dx plus q of x into y equal to 0. Say this is equation number 1. We have given this differential equation, right? Now assume that summation, let us write the series x minus x0 raised to n into the constants. So an into x minus x0 raised to n is the solution of equation 1. Now see, when I have written, something is missing. I have written summation an into x minus x0 raised to n. I have not mentioned for which values of n, right? I mean, n is equal to only 0 to infinity, n equal to 1 to infinity, or n equal to minus 5 to infinity, right? So it depends on the nature of x0, right? And this nature of x0 is the discussion of this topic, which is called singularities, right? So I am remaining this as it is. After discussion of singularity, we will fix the range of n. Okay, so what is the singularities? Suppose we have given this differential equation again. So now let us define the singularities. We have given this differential equation d2y by dx square plus p of x into dy by dx plus q of x into y equal to 0, right? A point x0 is called a regular point if limit x tends to x0 px, x tends to, if limit x tends to x0 px and limit x tends to x0 qx exists. This regular point is also called ordinary point. Ordinary point. So a point x0 is called either regular or ordinary point if limit of px and qx, right? These two functions we have given, the functions px and qx, both the functions must have limit at point x0. Then we can say that the point is ordinary point or regular point. Otherwise x0 is called a singular point. Is called a singular point. Now we have the bifurcation in singular point also. So suppose we have given a singular point, let x0 be a singular point for equation 1. Singular point for equation 1. Right. X0 is a singular point of this equation. What does it mean? it is not regular, it is not ordinary. What does it mean? Either this limit does not exist or this limit does not exist, right? Any one does not exist, then also it is called a singular point. If both limit does not exist or any one limit does not exist, then in this case x0 is called regular singular point. Regular singular point if, this is important, limit x tends to x0, x minus x0 into px, and limit x tends to x0, x minus x0 square qx exist. See, I repeat, we have given the differential equation, we fix one point, say x0, I check the limit at px and qx. Suppose both the limit exist, then it is called regular point. Any one limit or both the limit does not exist, then it is called singular point. Now suppose our assumption x0 is the singular point, then I check the limit x minus x0 into px, x minus x0 square into qx at point x0. If both the limit exists, then it is called regular singular point. If any one of the limit or both the limit does not exist, then it is called irregular singular point. So I am writing here, otherwise x0 is called irregular singular point. Irregular singular point. Let us note down this in structural format. I have given the differential equation d2y by dx square plus p of x into dy by dx plus q of x into y equal to 0. Right. I fix x0, then I do check this thing. Say x0 is regular point or an ordinary point. Other side we have x0 is singular point. x0 is singular. When I can say that it is ordinary, if limit x tends to x0 px and limit x tends to x0 qx, both exist, right? Otherwise we have this case, singular point. So in singular point we have again two cases, limit, right? This case is what? Regular singular point and irregular singular. Irregular singular. What? When we can say that it is regular singular, limit x tends to x0, x minus x0 into px, and and limit x tends to x0 x minus x0 square qx. If these two limits exist, then it is called regular singular. Now, see, in this unit, we discuss the series solution of this differential equation in two ways. If x0 is a regular singular point or x0 is, for this differential equation, dy by dx square plus q of x into dy by dx plus q of x into y equal to 0, we discuss the series solution when x0 is the regular point or ordinary point or x0 is a regular singular point. Right. So first, suppose we have given any differential equation, then how to find out the regular points, ordinary points or regular singular points? Let us discuss it with the exercise. 3x square y double dash plus 5x y dash plus x plus 2 into y equal to 0. Let us write the solution. What we have given? 3x square y double dash plus 5x y dash plus x plus 2 into y equal to 0. To find out singularities for x0s, we use the trick here. First, what we do? We convert the differential equation into the format which we have given, y double dash plus q of x into y dash. So I have to divide both sides by this 3x square. Then only I will get y double dash. Right. So 5x upon 3x square y dash plus x plus 2 upon 3x square into y equal to 0. And this will be y double dash plus 5 upon 3x into y dash plus x plus 2 upon 3x square into y equal to 0. So this is the equation number 1. Now compare equation 1, compare equation 1 with y double dash plus q of x into y dash plus q of x into y equal to 0. Right. So what is px? Px is equal to, see, px is this y double dash plus q of x into y dash. So q of x is 5 upon 3x. 5 upon 3x. And what is qx? Qx is equal to, say qx is this, x plus 2 upon 3x square. So this is equal to x plus 2 upon 3x square. Right. Now, the question is classify the singularities. That means we have to find out the point x0 which are regular or ordinary, and we have to find out the point x0 which are not ordinary points. That means singular points. And singular points, again, we divide into two parts: regular singular point, irregular singular point. So, what we do when we choose x0, that means we have infinitely many choices. X0 is any real number, right? So, the trick which we use is this. Let me explain here what is going here. What do we mean by ordinary points? That simply mean limit x tends to x0, limit x tends to x0 px, and limit x tends to x0 qx exists. right? Simply what do? We find out the points where function has the values. That is generally we observe what do we mean by the limit exists, right? So suppose x is equal to 0, then 5 upon 3 into 0 goes to infinity, right? So we find out all those points where the function has infinity value, right? Infinity value means what? Limit does not exist. And once it has a value, that means it has the limit, right? This is not the exact explanation, but we can use this trick, right? So p of x equal to 5 upon 3x goes to infinity when denominator becomes 0. So 3x equal to 0, so x equal to 0. Likewise here, qx, x plus 2 upon 3x square. So when x equal to 0, we can say that px and qx have no limits at 0, and so 0 is the singular point. What about other points? So first of all, let us write only this thing, right? Now you know denominator. Concentrate only on denominator 3x, right? So the denominator is this 3x, right? 0. The denominator is 3x square. So let us write 3x square equal to 0. So in both the cases, we are getting x equal to 0, right? So at x equal to 0, px is infinity, qx is infinity, right? So let us note down it. For x is equal to 0, limit x tends to x0, px, and limit x tends to x0, qx does not exist. Limit x tends to x0, qx does not exist. Therefore, x0 equal to 0 is a singular point. Is a singular point. So this is one way how do we find out the singular point. And this is the only singular point. See, let me draw the real line. This is 0, x0 is 0. At this particular point, right, px and qx are infinity. Now suppose my x0 is 1, say this is my x0 now, right? So what happened? X0 equal to 1 is 5 upon 3 into 1, which is 5 upon 3, that is the limit. 1 plus 2 upon 3 into 1, that is 3 by 3, 3 by 3 is again 1, right? Suppose x0 is equal to say minus 2, right? So 5 upon 3 into minus 2 plus 2 upon 3 into minus 2 square, right? So I mean accept 0 for all the points, right? Px and qx have limit. What does it mean? Accept 0, all the points are ordinary points. So that we mention here. How do you write in the examination? Therefore, the set of ordinary point is set of all real numbers minus x0 equal to 0. Right. These are the ordinary points. Now, x0 is the singular point, and singular point is divided into two parts, regular singular, irregular singular. How we can say that it is regular singular? If limit x tends to x0, x minus x0 into px, right? So now let us classify this point again in more detail, right? Now what we do, we write what is the limit x tends to x0, x minus x0 into px, and limit x tends to x0, x minus x0 square into qx, right? So this is limit x tends to 0. If you permit me, can I write x minus x0, right? That is x minus 0 is only x, so this is x. And what is px? Px is given here 5 upon 3x, 5 upon 3x. So here we can cancel out x and x, and so this is only 5 upon 3, and so we can say that limit exists. Here what happened? This is limit x tends to 0, x0 is 0, right? X0 is 0, so x minus 0 square is x square. So this is x square into, what is my qx? Qx is this, x plus 2 upon 3x square, x plus 2 upon 3x square. We can cancel out x square and x square, right? So this is the quantity, actually x plus 2 upon 3, limit x tends to 0, so substitute x equal to 0, so this is equal to 2 upon 3, right? So this limit exists, this limit also exists, both the limit exist, and therefore we can say that x0 equal to 0 is a regular singular point. Regular singular point. And this is the end of exercise. Again I repeat, in the classification of singularities for the differential equation, what you have to do, find out px, find out qx, then look at the denominator for which values of x the denominator is 0. So those are our singular points. All other points are ordinary points, right? Then for the singular points, look at limit x tends to x0, x minus x0 into px, x tends to x0, x minus x0 square into qx. Check the limits. If both the limit exists, then the point is regular singular point. Otherwise, it is irregular singular point. Let us discuss one more example. X square minus 1 into y double dash plus 5x into y dash plus x plus 2 into y equal to 0. Let us write the solution. What we have given? X square minus 1 y double dash. So I divide both sides by x square minus 1. So this is 5x upon x square minus 1 y double dash. Sorry, y dash. Plus x plus 2 upon x square minus 1 y equal to 0. This is equation number 1. Let us compare this equation with, compare equation 1 with y double dash plus q of x into y dash plus q of x into y equal to 0. Therefore, what is px? 5x upon x square minus 1. What is qx? X plus 2 upon x square minus 1. Right. What I told you, to find the singular point, what we do? We find out the denominator, compare with 0. So what is the denominator here? X square minus 1, x square minus 1. Right. So x square minus 1 is equal to 0. Say. Right. Let me use the different colors so that you can understand that this is the extra work. This is the denominator, x square minus 1. We are comparing with 0. X square minus 1 is what? X minus 1, x plus 1. And so we have two values of x is equal to minus 1 and x is equal to 1. Right. So these are two values. These are two values where function goes to infinity. So in this example, we have two singular points. Right. How do you represent? So right here, for x0 belongs to the set minus 1 1, right? Limit x tends to x0 px and limit x tends to x0 qx does not exist. Right, this limit do not exist, and therefore the set minus 1 1 is the set of singular point, is the set of singular points. Singular points. Right. Then which are the ordinary points or regular points? We have given all real numbers. We subtract or we don't consider only the points which are singular. So right, therefore the set of ordinary point is r minus 1 1. Clear? What next? We have two singular points and we need to check which one is regular singular point, which one is irregular singular point. So suppose we fix x0 is equal to say minus 1. Right. Then what we do? We need to check what is limit x tends to x0 x minus x0 into px. We also need to check limit x tends to x0 x minus x0 square into qx. Right. So this is what limit x tends to, what is x0? What is x0? X0 is minus 1. Right. Fix x0 is minus 1. So this is minus 1. Then this is x minus, what is x0? Minus 1. So x minus minus 1 is x plus 1. What is px? Px is given here, 5x upon x square minus 1. If you permit me, then can I write 5x upon x square minus 1 is nothing but x plus 1, x minus 1. Right. Okay. Can I cancel out x plus 1 and x plus 1? Yes. So this is nothing but limit x0 tends to minus 1, 5x upon x minus 1. What is this? Minus 5 upon minus 1 minus 1. I just substitute x0 equal to minus 1 here. So 5 into minus 1, which is minus 5. Right. X is minus 1. So minus 1 is minus 2, which is equal to 5 upon 2. Oh, so this limit exists. Now let us see what is happening for this one. So this is equal to limit x tends to x0 tends to, oh yes, actually I made mistake. This is limit x tends to, right. Limit x tends to minus 1, x tends to minus 1, and same here, limit x tends to minus 1. This is what? X minus x0 square, that is nothing but x plus 1 whole square into qx. What is qx? Qx is this, x plus 2 upon x square minus 1. So this is x plus 2 upon x minus 1, x plus 1. Right. Can I cancel out x plus 1? Yes, we can out 1 x plus 1 here. So this is equal to limit x tends to minus 1. What is remaining? X plus 1, x plus 2 upon x minus 1. Right. Now see, when you substitute x tends to minus 1, this is minus 1 plus 1 is 0. 0 into minus 1 plus 2 divided by minus 1 minus 1. So this is equal to 0. Okay. So here both the limits exist, and therefore x0 equal to minus 1 is regular singular point. Regular singular point. This is not the end of exercise. The another point is remaining. Minus 1 we have seen. Again x0 equal to 1. So how do you start? Fix x0 equal to 1. Then limit x tends to x0, x minus x0 into px. Find out the limit. Limit x tends to x0, x minus x0 square into qx. Find out the limit. If both the limit exist, then we can say that x0 equal to 1 is the regular singular point. May not be. So I am not discussing whether x0 equal to 1 is a regular singular point or irregular singular point. You find out by yourself. Right.